in this kind of period. And Enrico, which is working for Next Technology Tecnotessile in Italy, in Prato. And after taking a textile high school diploma, Enrico is also graduated in economics at the University of Firenze. And he works in the industry in quality control and developed a lot of experiences in the field with textile companies. Since 1996, he's working for Tecnotessile Next Technology as a project manager and has been in charge of a lot of European projects for H 2020, Cosme, Life, and is also a trainer in the textile sector. Enrico will explain you the last opportunities for SMEs working with TEX4IM and other projects we are working on. So Enrico, the floor is yours, and welcome everybody. Welcome Enrico.
Thank you very much, Stefan. Good morning, everybody, and welcome to this TEX4IM matchmaking event, which this year is going to be joined to Modtissimo Fair. So thanks a lot to our partners in Portugal, CITEV and the Portuguese textile cluster in particular, for hosting this important event. Now, today, I'm not going to take much of your time, so I will share with you some information about TEX4IM partnership and what the partnership can do to support the development and the growth of your project ideas. So if you don't mind, I will share with you my screen so that you will see the slides. Okay. Yes. Can you just confirm you can see my screen?
No. It's okay. Stefan? Enrico, it's okay.
Perfect. So, as I said, TEX4IM is a partnership and organized today matchmaking, which is going on until Wednesday, the 17th, sorry. And it's led by Next Technology Tecnotessile. We are a research center based in Prato, in Italy. And as you know, Prato is one of the most important textile manufacturing areas in Italy and in Europe, I would say. So we are very proud to show and to share our experience and our knowledge with the other textile clusters in Europe. TEX4IM is a partnership for industrial modernization of textile SMEs. It is a project funded by the European Commission under the COSME program. And it is composed of 8 different partners in 8 different regions in Europe. And here you see the partnership composition. We have 2 Italian clusters, Pointex and Tuscany Fashion Cluster, which is led by us. We have 1 cluster in France, Euromaterials, 1 cluster in Spain, which is Ateval in Valencia region. Of course, so we have CITEV in the Portuguese textile cluster in Norte region. We have the Romanian cluster, Astrico, Northeast, and the Czech Republic cluster, which is Klatex, and the Swedish cluster, which is Smart Textile, based in the University of Borash. So this is a sustainable partnership because it will not stop its activities at the end of the project, which is going to happen in April, at the end of April this year, but it will continue. There is an engagement by the partners to continue the cooperation also in the future, to support industrial modernization of our SMEs, as I said, and to feed cross-regional cooperation opportunities. So the project is about the creation of a stable incubation acceleration mechanism for triggering innovation in our SMEs. So it is essentially an innovation enabler. The main thematic objectives of our partnership are the same of the textile and clothing strategic agenda, which is based on circular economy and Industry 4.0, which are advanced manufacturing, which are the two pillars of the future development of textile and clothing industries, but also digital technologies, e-marketing and social communities, advanced textile materials, and new business models for new value chain creation. So the TEX4IM is, as I was saying, a mechanism, a partnership that has established a stable mechanism for incubating and accelerating new project ideas. So investment projects by part of our textile and clothing SMEs. And it developed also a strategy for textile and clothing sector in Europe and its industrial modernization. And this, the creation of this mechanism is based on some specific tools. One of them, and the most important one maybe, is the matchmaking event. So the event that we are going to arrange today and for next 2 days is part of the support that we are trying to give to companies to set up, to flourish, to generate new project ideas. So our main target is SMEs, so the small and medium enterprises, and in particular those of textile and clothing sectors, but also cluster staff, because TEX4IM has a number of side activities to raise skills and quality level of the cluster staff members, and also policymakers, because we are going to support them through a series of recommendations that will support the future policies of these policymakers. So we are going to support by doing networking activities. So matchmaking and brokerage are part of these networking activities because they normally generate business opportunities, business cooperations. We want to build strong competencies and enable and promote innovation. So we have set up a specific toolbox for the facilitation of cooperation between the SMEs of different partner regions in many different thematic areas that are the ones that I was mentioning before. So do not forget circular economy and Industry 4.0 are at the base of our strategy. So we want to support the matching realization, but also the development of ideas coming from the matches being set up during the matchmaking and the other opportunities offered by TEX4IM to create strategic alliances. I'm going to explain in a minute how we will give this kind of support. First of all, I want to before doing that, sorry, I want to remind the matchmaking that we have already performed in 2019 in Stockholm, in the beautiful Stockholm in November. This was before the pandemic, and of course, this matchmaking event was done in presence. It was really very effective because there we set up almost 100 meetings, B2B meetings, with the participation of around 50 companies from all over Europe. So we were able to mobilize SMEs from the 8 different textile regions to go to Stockholm for a meeting, not only Swedish companies, but also textile companies coming from the other 8 regions of Europe. So the mechanism that TEX4IM has generated is really to create the conditions for SMEs to meet and get to know each other, which normally happens into fairs or trade exhibitions. But in this case, the form of matching was done through the matchmaking system. So we use the BitMatch platform, the same platform we are going to use today and in the next 2 days for the matchmaking event that will take place together with Modtissimo Fair. Unfortunately, as it was said by Stefan, this year we have to work online, we have to work by remote, so we are not able to mobilize companies to bring them there. But in any case, we hope this will be very successful. At a glance, TEX4IM, as I said, is about to finish. So the funding period from the European Commission will end up in April, at the end of April 2021, but the activities of the partnership will continue later. So any companies that is participating to this matchmaking event is warmly invited to drop a project, an expression of interest about the idea that they want to carry on in our website. So there is the possibility, there is a very simple format with very few information to be delivered that you can find in the website. You can go there and fill the expression of interest, and one of our partners will get in touch with you to support you in the development of this business idea that will ultimately end in the realization, in the preparation of a complete business plan that the companies that want to set up the cooperation can use for funding, for a public call for funding, like the one of the next Horizon Europe program, or even to a private source of funding. So this is very important. So the explanation of the mechanism is that when you do the B2B meetings in this B2Match platform of Modtissimo Fair, you can drop an expression of interest into the website of TEX4IM that I'm going to show you later, the address, and you will be contacted by one of our cluster members to develop the business plan related to that project idea, of course, provided that this project idea is valuable and there are the conditions, technical conditions to be developed. And this support by our partners is totally free for the participating SMEs. So there is a mechanism that I'm going to explain here for the creation of a portfolio. We are going to generate a portfolio of project ideas. So there are already 19 project proposals included in this portfolio, but more will be included there after the matchmaking of these next 3 days. So don't be shy, and if you have issues or difficulties in sending your expression of interest through the website, please call one of your cluster reference. They will be willing and open to support you, and they will provide you all the information you need. Once you will fill the expression of interest, of course, we will develop the project idea a little bit further, and in case it will be worthy, we can include these project ideas into the TEX4IM portfolio. Then the best ideas from this portfolio will be selected for the generation of business plans. Okay, so this is a very, let's say, short, brief structure of what the business plan includes. But as you maybe already know, the business plan, beyond developing the technical details of the proposal, so the problem and how the problem will be addressed, we will develop a market vision. So we will also going to support you in the definition of your target market, who will be your customers, how many products or services, new services you will introduce into the market, what are the revenue streams coming from these new products or services, what is the IPR, what is the cost and the revenues budget for this idea, etc. So it's very complete, and it really supports you to go to the market with a new idea, with an innovation. So at the basis of this TEX4IM mechanism is the innovation. So it must be an innovative idea, and it must be cross-region or cross-sector. So we aim at having cross-sector ideas, innovative ideas, like, for instance, advanced manufacturing and textile, one of the textile manufacturing operations, so spinning, weaving, dyeing, finishing, etc. And we also aim at having a cross-border cooperation. So it is very important that this cooperation include two different actors, one SME, probably the SME will be from textile and clothing sector, and one other actor, which can be the technology provider, like, for instance, an R&D center, a university, a technology institute, or another in manufacturing company, which can be an SME again, or it can be also a large company. So the important is that the cooperation is innovative. So the idea is innovative, and there is a cross-sector or cross-region dimensions. So if these conditions will be met, we will support you with the development of a business plan and in the support for the finding of the right financing for you, which can be private or public. And this support will be totally free for you, for the SMEs, and will be given by the cluster partners of TEX4IM. So, as I said before, this is the link to our website, where you can find the format, the template. It's an online template, okay? It's an online format, so it's not difficult. It's very few information that you need to send to us by filling this project idea expression of interest. Once we will receive this expression of interest, we will contact you and we will develop further the idea. So please visit our website, which is tex4im.eu. Then you go in the specific section of the website where the expression of interests are available for filling, and explore our website, because it's full of other news and information which could be useful for the support of your project idea development. Here you have also my email address in case you need to ask for any doubt or any information that is needed from your side. So this is all, I guess, for the presentation of TEX4IM. If you have any question, I will be available at the end of this session to provide information. So we are here, we are 8 clusters in textile sector, and we are here to support the development of your project idea. So please feel free to share your ideas and your innovation with us. Thank you very much for your attention. I give the word back to Stefan. Thank you.
Thanks a lot, Enrico, for this great presentation. What is important in Enrico has said is that it's the word cooperation and working together, because what is true and what we are sure is that one day, we hope it will be soon, that this crisis will be behind us. But what is true also is that we will need to go back to business, but going back to business means also that probably going back differently to business, because people will change, the markets will change, and probably the needs for innovation, especially for SMEs, will be will be really strongly needed. And so clearly all those clusters through TEX4IM and all those partners, we are here to help you going faster and going back faster to the market. So don't hesitate to interact with us if you have any question. And also what is true is that partnership across your country, partnership across your region, but also partnership across Europe will help you going faster, and will help you to find the right skills and the right technologies where is needed and as soon as needed. So thanks a lot. We will go now to the first, to the main part of this day, which is the technical textile journey. And I will give the floor to João Gomes, which is specialized with a master degree in materials processing and also a degree in physics from University in Minho in Portugal. We used to work since lots of years for University of Minho in electroactive materials, but since 2007 is working for CENTI, which is a Portuguese center, R&D center next to CITEV, and specialized in printed electronics, smart textile, multi-component fibers, which is one of the good R&D center in Europe for textile, but also electronics company. And now it's also position of chief operation officer in CENTI and working with an overseeing development of new technologies. I will go fast because we are just a few minutes late, but Joe will take us on board on his journey on smart textiles. So Joe, the floor is yours. And so also don't hesitate to ask any question. We will, if it is a direct question, we will ask them straight after his presentation. And also we will wrap up with question at the end of all the presentation. Thanks a lot. Joe, you can go.
Hello, good morning, Stefan, and thank you for the introduction. Also, thank you to Anna for inviting me to give you this brief overview on smart textile trends. Just let me share the presentation with you. Just a moment. Okay, so. Okay, so I think today that what we want to discuss, or at least give you a brief overview, is just give you some insight on the key challenges that we are facing regarding the introduction of basically electronics and smart systems, but also other functionalities into textile structures, either technical textile structures or garments for other technical or non-technical applications, or let's say fashion applications. So the concept, and I'll go into the outline of our discussion this morning, is really I'll just give you a few slides about CENTI, just a brief introduction. I think most of you already have been acquainted with CENTI, or at least heard about our technology center. So I'll skip through it quite quickly. I think afterwards we need to really have a framework on what we comprehend about, or at least the comprehensive response about what are smart textiles, what do we include in the definition of smart textiles, but mainly what are the main challenges facing the integration of electronics and smart systems into textile structures. Of course, we have two main challenges, the integration and the data integration, which are both one and the same, but also separate in terms of the way that we approach the technical aspects of each one. And I'll give you a few examples of some projects that focus on the integration of smart systems at fiber and yarn level. So one of the technical approaches dedicated to the integration into these materials, but also hybrid technologies, which are the most common technologies, which tries to hybridize textile technology or textile processes with electronic manufacturing processes. So without further ado, just a few words about CENTI. CENTI is a private non-profit research and technology institute located in north of Portugal, right next door to CITEV, the Technology Center for Textiles in Portugal. It was born out of a spin-off from CITEV, but also with a collaboration of the three main universities from the north of Portugal, Aveiro, Porto, and Minho, which were joined by CITEV, by STIC, Technology Center for Leather, and SEA, the Technology Center for Automotive and Aeronautics. We are, of course, driven not by a sectorial approach. So unlike CITEV, we are not focused solely on the textile and the textile industry. So we are multidisciplinary, cross-sectorial research institute that focuses on the development of new materials and product development or product innovation. And therefore, we are a multidisciplinary group. We include a lot of backgrounds into our team, and we focus, again, specifically more on the textile side, on development of multi-component fibers or special polymers integrated into these multi-component fibers, development of composites as well, the development of smart materials linked with the development, of course, of smart devices and smart electronics. Also, the development of multifunctional coatings, the introduction of added surface functionalities, not only on textile substrates, but mainly on polymeric substrates. Of course, textile substrates are one of the major substrates that we work with. And of course, the development of printed and organic electronics for a wide range of applications. We are not solely a research institute. Our main the main bulk of our activity is linked with technology transfers, so the development of products and new processes for industry. So we tend to focus on TRL 3 to TRL 6 type of projects, and we organize ourselves in terms of industrial offer into these three main major macro sectors: automotive, aeronautics, architecture and construction, sports protection and well-being, where we normally place textiles, although textiles have a wide range of applications that encompass all of these three macro sectors or wide sectors. And of course, we organize ourselves also into three main vertical lines of integration, lines of know-how linked with functional materials and solutions, smart materials and systems, and product design and product engineering, an area that is more focused on developing new processes and developing product design as well. So coming to the topic of our discussion this morning, I think it's really important to understand what are the main challenges facing smart textiles and development of electronic textiles for the past, I would say, 20 years. So for the last 20 years, I think that the main issue has been a push that has been given. The push has been given not by the market, but by the technologists. So one of the issues that we are confronted with is really this push by the development of technology, and we are trying to push the technology onto a higher TRLs. But there is no competitive advantage when we reach higher TRLs in the transfer to a product or an industrial process, since there are more competitive alternatives on the market, or more competitive technologies that are more easily transferred to the market. One good example is really the Fitbit type of health trackers, or at least these bracelets that track your activity daily. 20 years ago, we were trying to introduce heart rate monitors into T-shirts and other types of devices that would measure temperature, etc., and also measure the distance and the steps that we gave during the day. And that technology had a competitor, and that competitor was, of course, mobile platforms, or in this case, wearable electronics. And these wearable electronics were more easily transferred to the market with less complex processes integrated into them. So they were more competitive and more easily transferred into the market. So the issue here is, for smart textiles specifically, is to detail the user experience that we've been focusing on for these last years. So the user experience is one of the main drivers and the main challenge that we have to transfer these technologies onto successful products. And of course, the more technical challenges that have been the driver of the development of technology, and not the user experience. So we have to replace the technical challenges with the user experience and the market demands, but also some critical factors. And here the critical factors are really the requirements where textile can be the key to solve an issue. So if the textile component is the competitive advantage in itself, let's say you have here a clear example of personal protective equipment, and you can't do without that technical aspect of this product, then the integration into these structures is more viable, or will be not only feasible, has to be feasible technically, but it will be more viable in terms of the approach to the market. So quite clearly, for the last years, I think the user experience has been one of poor usability, mainly stemming from misadjusted functionalities in the integration of the components into the textile processes that yield some cumbersome type of devices that we have to wear, which is not really what we intend. This, of course, leads up to several design restrictions and a wide range of lifetime and maintenance issues as well for each of these systems, and a lot of comfort and user friendliness issues regarding with the maintenance of these textile garments or these textile structures. Of course, since we are combining two different industries, we are also manufacturing really complex fabrication and assembly processes, since we're trying to combine a purely textile manufacturing process with an electronics assembly process, and that is not in every case very feasible. And of course, this also leads us to a very incoherent value proposition and complex data management services. That is to say that the management of the data generated is very complex, and it's not always available. And the value proposition, the value that we're integrating into the product, is normally something that the market is not willing to pay. So the willingness to pay is normally a very difficult hurdle when we combine these two technologies, two manufacturing technologies, into a single structure. So the main challenges, we believe, are to create more designer-friendly technologies, and that is only possible by introducing what we call user engagement and usability testing. So it has to make sense that it's a textile, electronic textile. That it has to make sense. It has to be. We need a competitive advantage by using a textile structure, and by using the integration of electronics into that structure has to provide a significant competitive advantage when approaching the market. That leads us into this third point of accessing suitable business model and the upscaling of the processing methods. These are both in the same, because we don't want to fall into the trap of the incoherent value proposition that we discussed. And of course, in my view, one of the major hurdles that we have is the development of these interconnection technologies, both data interconnection, so data relay technologies, and physical interconnection between hybrid systems, electronic hybrid systems, and the textile manufacturing processes. This leads us to, let's say, a sum of these critical factors that also include trends. So fashion and technical trends are also one of the critical factors. We need this function advantage given by textile as well, so the usability or integratability advantage given by the textiles, and that needs to be encompassed or included into a specific market requirement. And technically, what we want to focus is on the application design, so the process and the technology. So we want to focus on the functionality, has to be so the technology that we integrate needs to provide an added functionality. It's quite clear to demonstrate the added value that we're integrating. So what is the functionality that we are providing that no other structure, or either by the usability of that structure or by the functionality in itself of the system, has a clear competitive advantage, and no other system is able to provide it. And of course, having a sustainable service model or in a sustainable life cycle, that is to say that we have to consider the whole lifetime of the device as well. So in terms of key technologies for the integration, I think we can say that we've suffered for a long time of integrating wires, and this is in the sense of electrical wires, and trying to combine them with textile processes, which is not feasible in most cases. This, of course, leads us to very cumbersome embedded systems, in which we are trying to integrate rigid hardware or semi-rigid hardware, and sometimes flexible PCBs, but they also include rigid SMDs components into textiles by simply weaving them, or in this case, in some cases, embroidering these systems. And of course, they are very cumbersome, very uncomfortable, and also the development of these interconnections. And here are one of the most critical points. These interconnection systems are really fragile, and we don't have a specific process that is able to interconnect flexible or semi-rigid and flexible systems in a textile process, and also assuring mechanical stability and electrical stability. So these are the main issues that we face with interconnections. So how do we try to solve these issues? So basically, we are trying to combine surface technology, printing and lamination of devices, so print electronics onto textiles directly, or the hybrid and embedded approach, in which we are trying to embroider, cut and sew, or manufacture some devices. So a process in which we include SMD devices into a single yarn or fibers. And of course, the fiber and yarn approach, in which we are trying to manufacture the devices directly in the fiber or inside the fiber or the yarn, and then introducing that fiber and that yarn into a conventional textile process in which the devices are being integrated as a normal fiber, as a normal yarn. The yarn and surface approach, of course, leads us to a significant hurdle, which we need to introduce also the capability of processing data or acquiring data and relaying data. That's why we need to introduce these hybrid systems. Hybrid means that you might have a flexible electronics or textile electronic device, but it needs to be combined with a rigid or SMD component that provides you with the capability of processing data and relaying data. That can be achieved by mainly lamination, thermoforming, or printing, but also by introduction of these conductive yarns or dielectric yarns. The combination of dielectric yarns and conductive yarns normally, and with a specific design, normally enables you with a fully textile process to also develop some electronic components itself. So these approaches, these hybrid approaches, have some pros and cons. Well, to summarize, the pros are mainly at the wide range of application technologies that we are able to integrate into the most diverse of textile processes, ranging from knitting to weaving, jacquard weaving, and to embroidery. But also it also includes a very complex value proposal. So when we're combining printed electronics on textiles with the assembly of SMD components, so you can have a microprocessor and a Bluetooth device that transmit the data or relays the data to an external platform, it usually leads to very cost-intensive processes and very complex assembly and maintenance devices, so structures. One of the other issues that we would need to discuss today is the integration of data. So nowadays, the requirements are that we need to integrate the digital acquisition of data that it's being generated in external platforms into external platforms for data processing. So we might have integrated platforms, so like a sensor or some actuator that it's integrated into some structure. But normally these individual sensors or integrated technologies need to relay information to external platforms. This is what we call ubiquitous interactivity or ubiquitous computing, in which we're trying to sensorize every type of surface or communicate with every type of structure that we have or come in contact with. Of course, when we come to e-textiles, that's even more critical, because we normally want to acquire some data or monitor some data that is being sensed by some specific components that are integrated in some textile structure or interact with that surface, with that textile surface, and we want to acquire that data and process it in an external platform so we can visualize the information, or at least interact with the information. So this ubiquitous computing has led us to, specifically in this case, this is a good example in which we are trying to integrate a fully monitored PPE. So PPE has been one of the areas that technical textile areas where the integration of e-textiles and smart textiles has been more prolific and also more successful. You have here an example of the objectives and the focus, which is to integrate a full range of monitoring systems inside of the protective equipment. And of course, this means absolutely nothing if we cannot extract the data, process the data in real time, and relay the data back to the user or to a centralized platform that monitors hazardous conditions or operational conditions. So this integration of data management systems, so that integration of communication protocols, communication technologies into the textile structures is also one of the major challenges that we have currently. So how are we addressing these challenges? How are we going about and developing technologies that are able to comply with these requirements? Well, at Senti, at least, we've been exploring quite heavily the development of smart fibers. So these smart fiber technologies normally follow this type of pipeline in which we start with the materials development, and then we start trying to integrate these different types of materials or different properties into a single fiber structure, or develop a specific yarn technology that enables us to build these smart devices based on the assembly of different yarns and different fibers. So fabricating a smart device using a fully textile process. Of course, the development of the fiber itself enables us to integrate the smart device into the core of the fiber structure itself, following this very straightforward pipeline in which we develop the fiber, develop the device, and then we use weaving, knitting, or other textile structures or textile processes to interconnect the different sensors and different devices there are in a single structure, and therefore manufacturing a fully textile device that is interconnected via a textile process with an external platform as well. Here you have some examples of some projects, PowerWeave, 1D Neon, and project called Mastro, that have been trying to integrate both sensors and active devices like photovoltaic solar cells into the fiber structure itself. You can check some information later, but I can give you some examples, some additional examples from some national projects. And here you have an example of a hybrid system that is focused on a jacquard weaving process, in which there's a yarn-based process that enables us to assemble a specific SMD component, in this case LEDs, and assemble the LED and bond them, a low temperature bonding process that enables the system to have good mechanical performance and good electrical performance in a single stage. So you basically have a jacquard weaving process that gives you the matrix that you require for the assembly of this, these LED systems. And then you have a pick and place system that is also textile, that searches for the specific points where to position the SMD, the LED, and then bond them and interconnect them in a single stage. So it's basically a textile electronic hybrid system that is based on a yarn technology. And here you have an example of another national project, a Portuguese national project, in which we are trying to develop some sensing devices at fiber level. So we started by developing piezoresistive sensors inside of the fiber, so extruding the fiber as a sensor itself, interconnect them via the textile weaving process, and then manufacturing a thermoset composite that is able to monitor vibrations and monitor also mechanical stimuli. Normally, these thermoset composites are being used in windmill shafts and also to the structure of airplane wings, and all types of applications that have thermoset composites that are under extreme mechanical stress, and you need to monitor that stress. As for hybrid technologies, we have some more wide range of applications and examples that we can show you. Here, I would like to show you two examples of. One is a printed approach. So you have a surface approach in which you take a fully processed textile woven a woven textile substrate, and we print a capacitive matrix, and we overlap that capacitive matrix with another textiles, and we make this multi-layer structure that is able to operate as a capacitive touch sensor. This capacitive touch sensor is actually a capacitive matrix, operates in a very similar fashion to your cell phone screen, and you can monitor movement and multi-touch gestures. And the same thing can be done strictly with the structural approach using jacquard weaving and using conductive yarns. Here you have some examples. Just let me quite quickly, very quickly, show you the videos in which you have my colleague here not only positioning the finger and it can monitor the gestures, but it's also multi-touch. Here is using 2 fingers and has the response. This is the fully textile approach, and this is the printed approach, in which it's basically monitoring objects, not only the position of the object, but also the interaction of the object, that is to say, the mass of the object. So very quickly, just to give you an overview of the processes that we are using for hybrid systems, ranging from printed actuators to pick and place and assembly encapsulation. So this is normally a combination of textile and printing and assembling processes that enable us to do both the yarn integration with lighting, also a very important approach. But normally these are the processes that we've been using for assembling these different devices. So as a summary, I would like to stress that the main challenges going forward are really to focus on the applications that the market gives us some specific demands. So not relying solely on technology push, but also trying to get in contact with some technology pull, which is the case that we've mentioned for PPEs. There's a clear market demand, a technology pull for introduction of smart sensing functionalities into the structures itself, so into the garments, the protective equipment itself, and also the digital integration. So we need to integrate the capabilities of relaying, processing data, and exporting that data into external platforms. Of course, this leads us to additional challenges: how to power these devices, how to power these devices continuously, how to recharge the powering of these devices, or also the follow-up challenges as well. But also this material sustainability, in which we want to manufacture these devices, but we also need to have a sustainable life cycle for all of these technologies. So I overextended my time, so for 5 minutes. I think it was, I hope it was worth it. So thank you for your attention.
Okay, thanks a lot, for this great presentation. If we can wrap up in 2 words, and what it will be opportunities for discussion later. It's basically things about your market, user demand, which is the beginning of your journey. Obviously, you need to have skills and resources, and probably to mix and match different skills and resources within your companies and also outside of your companies, because it's not so. You will need to integrate different technologies. And so is why we definitely need a European smart textile accelerator. And is why I give the floor to Judith, which will present the European Smart Textile Accelerator, which is running on behalf of the European Technology Platform. Thanks a lot, Judith. The floor is yours.
Thank you, Stefan, for the presentation, and thank you as well, Anna, for introduction. For giving me the opportunity to present today here. I'm going to ask a technical question. Everyone is seeing my slides? Okay, perfect. So, saying that, as Stefan said, SmartTex is a 3 years collaborative project that is funded under the Horizon 2020 Research and Innovation Program. And the main goal is to support a smart textiles manufacturing value chain in Europe through acceleration, funding, and coaching to SMEs and startups. So we are a consortium of 13 partners from 7 different EU countries. And well, We have been, we target the smart textiles in the project as a textile fiber or fabric-based product, providing a smart function based on an integrated electronic component. So as we have been saying, I mean, Joa already mentioned and Stefan as well mentioned, I mean, there is a growth potential in this market, and this is why we focus that project. And from the data that we are going to say, that I'm going to explain you right now, you will see that it's a real need. So, I mean, the target markets for the project are protection, sports, health and well-being, and industrial applications, including transport and interior. Obviously, it's a project that has been running for 2 years already, well, almost 2 years already. So unfortunately, the last call closed on 15th of February. But I have to say that overall, the 3 calls, we had an amazing success in participation, in SME participation. And I mean, the level of the applications were quite high. We have received, for give you a bit of number, 301 expressions of interest, and I think around 90 applications in total. So moving forward for the funded SMEs and the funded SMEs in the first call and the second call, I cannot include the third call because the results will be announced between today or tomorrow, so I cannot include in this presentation. But I mean, in the first call, we received 35 eligible applications and 9 projects were selected, and 16 SMEs have received funding, and the total budget allocated on this call was 706,000 euros. For the second call, and here I have to stop a little bit because it plays an important role, the community that I will talk later on, and as well the work of the coaches, Stefan, for example, or Anna, that they are here, because we received 27 applications, but 10 projects were selected, and a total of 21 SMEs have received funding. So here we see interaction and interaction among different countries from Europe. And well, yeah, 1,030,800 was allocated into that call. So in general, and with the 2 calls, we have allocated 1,800,000 approximately among 13 different EU countries. And now, I mean, I would like to show you a little bit which projects has received funding and slightly a bit what is the function. So in the first image here, this is the airbag inside. It's a project focusing protection, especially for motorcycles. And as the word says, the idea is that when the motorcycle falls, the airbag activates and it avoids having leg injuries or hip breaks. So the second project here is a trolley for babies, and it's focused on well-being. And you put your baby and you can monitor the temperature, heartbeats, and I mean, it's like to give a little bit of relaxation to the parents. And I mean, the third one in this slide is the sensing text project. It's a sensing mat, and it's focused on well-being, and it's a mattress for especially wheelchair people to avoid having sores. They control the pressure when they are sitting, and this is an idea to help them to avoid the sores. The fourth project here is for athletes. It's a top for athletes. We cannot see, but it has an integrated sensors that can analyze the sweat and then tell the athlete if they need to drink or eat or what nutrients is missing to improve their training. And the last one here is a top that it can be really used for all of us that we spend hours and hours sitting in a chair, is to control the back position and to avoid back injuries. So, I mean, for the second call, I have as well, I selected as well 5 projects. I mean, here, the first one, this part here, I mean, I have really early stage prototypes because the projects are running and they are not really open to show the real prototypes. They are like really stages ones. So this part is from a company called Consensus, and what they want to do is to heat a caravan without the need of electricity. So it's a heating textile. This one here is from Marina Reis, is targeting protection, but protection in Formula One. Here I think it's really small. We can see 2 sensors, and these 2 sensors, what they do is they monitor the constants of the pilot. And that one here in the middle, it's for a seat baby. It's targeting well-being, and what it does is when the baby's in the car, it controls as well the constants, and as well it has a connection with the mobile phone in case the parents, that sometimes we had those fatalities that the parents forget the baby in the car and it just pass away. So to avoid that, it has an electronic connection that informs the parent that the baby is still in the car. And this project here, the ePod, is in well-being as well, and is focused on teaching the children to use the bathroom. And that glove here is like it's for industrial applications, obviously, and it's like helping the workers to do all the time the same move, and as well it has some sensors in the fingers that can control, that can give you some data. So, I mean, moving forward for the activities that we have done and we are continue doing, and now I'm going to be focused on our SmartTex community because it's really important. It helped many of the projects that we have seen to create consortia and to create business partnerships. So, I mean, during the project at the beginning, we have organized a series of workshops to launch the project, to explain the goals. And we really hope that in the coming month that we are able to do the same for the dissemination workshops, where you will be able to meet our funded SMEs and as well to know the potential of the community. We hope to have these events from September, October, and we hope they will become physical events and not online events. Here you have a few pictures about these events. And now I'm moving to the community because it's a part of the project that is going to be active. And it's going to be, I mean, we hope it's going to continue after the end of the project. So in the community, what you can do, you can create, a company profile. And in the company profile, you have here the possibility to write inquiries. For example, I'm looking for a partner to in flexible electronics. And well, this inquires if you have completed your profile. Our community manager, she normally posts them in social media, in our social media, in Twitter or in LinkedIn, or as well they promote them via the newsletters that I will talk later on. And apart from that, we have an organized community. So if you're looking for flexible electronics, knitting textiles, or companies like that, you can just tag them and they will appear the selection. As well, if you want to introduce your company or your objectives or what you're working on, we have the possibility that you can upload a presentation, technical document, wherever you feel good to share with the community. And apart from that, we create as well, thanks to Eura Materials, that is Stefan, the self-assessment tool, that it's a tool that takes you 30 minutes, but it helps you to identify your weakness and your strengths in the SmartTex field. So why to join the community, apart from all the points that I already mentioned, that it's create a business opportunity, share information with potential business partners, assess your strengths and weaknesses with our self-assessment tool, and build new partnerships as well. It's really, I really encourage you to join us because we have a series of webinars, more or less 6 weeks, 7 weeks, really focused on one topic related to SmartTex manufacturing value chain. The next one probably will be beginning of April. I don't have the title yet, but I mean, I encourage you to follow us in social media and in our website because it will be posted quite soon. Apart from that, we have our website, smarttex-europe.eu, where you can find all the information about the webinars. If you register to the community, you have as well the information of the past webinars, you have the presentations of the speakers and the recordings. Moreover, you have as well a showroom where you can see the funded SMEs, what they are doing, the developments of their projects. And on a third point, you have our blog with really interesting interviews. So as I was saying as well, we have two newsletters. One is a public newsletter, but if you belong to the community, we have a more internal newsletter. It has more information about the inquiries, new members that they are joining, and for future how to register to the webinars, like when we upload the information of the webinars and all that. And I really hope that you join us, because we are really building a really interesting community. And I think if you want to know by numbers, I think that nowadays we are 700 and growing members of the community. So I hope this is the end of the presentation, I think on time. And if you have any questions, I will be happy to answer them.
Thanks a lot, Judith. And I think during the last round, we will have a few questions and lots of questions I expect for you. Definitely, I think that for all of you joining the SmartTex community is really the first step moving in smart textile world, because you have a strong and huge community available for you. And as you saw before with Joao and then with Judith, we definitely, and you definitely needs to have some partners to be on board this exciting but difficult technologies and market. So last but not least, we will give the floor to Jose, another J. After Joe, Judith, it's Jose. And we will explain us about opportunities through another project called Smarties for adoption, ramp up, and transfer of emerging electronic solutions. So Jose, just to briefly working for Senti since 2008, and is a specialist in material structure, smart textile and sensors. And in Senti is a leader of the printed electronics teams, and is overseeing the work conducting in several projects. So is really your expert if you want to move on these fields. And so Jose, the floor is yours.
Thank you, Stefan. I'm going to start by sharing my presentation. I believe that you should be seeing the slides now.
It's okay, Jose. It's okay.
Okay, thank you. I would like to start by thanking the organization for this opportunity to present my project, Smarties 2. So Smarties 2 is a part of a European initiative, Smart Anything Everywhere, whose objective is to promote the European digital transition in these different industrial sectors. In a way, this initiative is also a kind of preparation for one of the major objectives of Horizon Europe, to promote European industrial competitiveness. As you can see from the list that I'm showing now in this slide, this project is already the second one financed by the Commission under the same theme. And therefore, I think it is important to make a brief overview here. You can see that now in 2019, we have Smarties 2, and in 2017, it was Smarties 1. So, Smarties project is already a third phase of a process that started in the FP7 program with the COLA project, which had the main objective of promoting the integration and use of printed and flexible electronics in different sectors. The COLA project developed the concept of what the next phases could be, with the first Smarties project starting the creation and activation of the network the exploration of business models and establishment of the Smarties brand. The Smarties 2 project arises naturally in an attempt to expand the network and prepare a sustainability model for the establishment of a European network in the phase 4 that I'm showing, whose objective will be to start the creation of a service network that allows support to companies at the European level. In terms of the consortium inside of the project, we have 8 RTOs from all over Europe, 3 business partners that help in our application experiments the companies to create business models for the new products that they develop, and also 3 clusters. Our idea was to have representatives from all areas: consulting, research and technology development, and business development. In terms of the core objectives of the project, Smarties 2 has 3 base objectives. The first one is to promote an easy access to digital innovation, ensuring growing awareness and interest in opportunities of flexible electronics technologies. Our idea is to do this by providing easy access to the latest flexible and wearable electronics-driven digital innovations and experimentation facilities to early adopters and new non-digitized users in order to support them in gaining competitive advantage through early technology adoption. Digital innovation, we expect to be able to enable it, not only by the support of European third-party service providers, but all that will support key stakeholders in building value chains and in valorizing their skills, relevant skills, and also by the RTO partners that are part of the consortium, and that will provide access to state-of-the-art technologies, pilot line facilities, and research and development skills and evaluation tools. As for the second objective, it is to provide high-value services to innovating companies. As you can see, these services are being tuned currently to the language of the ICs in a way with the objective of understanding their needs and translating them to practical solutions through the creation, for example, of collaborations, providing training actions, engagement with local industry actors, and access to finance. These services will be particularly adapted to companies not yet advanced in digital technology adoption, with the highly innovative ones having already passed the digitalization barrier. Finally, as for the third objective, as I mentioned before, we intend to create a pan-European collaboration network for flexible and wearable electronics. And this will, we are trying to build a sustainable pan-European network of regional digital innovation hubs in the field of flexible electronics, in alignment with the digitalization European industry strategy. For the project, shifting the view on innovation actions towards post-project sustainability and pan-European collaboration is a key objective in the project to encourage and often support and try to support local SMEs to open their facilities to companies outside the territory and to collaborate with digital innovation hubs outside the region when needed. This is all part of a rational share between Smarties 1 and Smarties 2, where we intend to support the European industry and reinforce its competitive advantage by providing acceleration support for the integration of flexible electronics. You can see here, we hope and we want to facilitate technologies uptake, transferring technologies from a more research state into a more industrial stage, and facilitate those technologies adoption by the SMEs. Of course, this faces several challenges, not only in the technologies side, but also in the market. You can see here several of the challenges that we identified. For example, just in terms of technologies, we have the cost of equipment and materials, interconnections is still a serious problem in, for example, smart textiles, application of printed electronics into smart textiles, scalability, transferring some technologies and development of some products using harder to transfer to an initial stage of some creation or development process still offers some challenges to achieve, let's say, for example, the necessary speed of production or lower its cost to be applied. We also have product design and also at the end, very important, the rules and regulations. And you can see here for each challenge we have a plan, and in this case of rules and regulations, we intend to open a collaboration or create a collaboration with standardization commissions to create specific rules for flexible wearable electronics. On the market side, we have here identified 4 challenges. We have the technology, manufacturer, and suppliers, which we intend to create a platform that connects the different entities and reduce the distance between them, as I mentioned in previous slides, trying to make it easier for the different ICs and companies to access the technologies that they might need to develop their ideas and products. And also to reach out to the investor community and identify and contact financing entities. And also, of course, again, the creation of the pan-European network and creation of lighthouse regions to boost a sustainable network. Now, after this brief presentation of the project, I'll move to some of the opportunities that we have inside the project for SMEs and ICs or innovation companies. So, part of the project is the opening of several calls for application experiments that are, in fact, small collaborative projects with the duration that should have a duration between 9 and 12 months, most of them 10 to 9 months, where the idea is to have technology transfer utilities, where a company has a specific challenge or an idea. Maybe it can be at the early development stage where the idea is to create a prototype, or at the more industrialization stage where they already have a small prototype, but they just need help in transferring that prototype from a laboratory environment, for example, into an industrial development environment. So for each application experiment, we can have 3 partners inside the IC, the company itself, a business partner, and then research and technology partner that can be an RTO from the consortium itself, or a technology provider that has a connection to the project, but it's not directly part of the consortium. Besides the 3 partners, of course, there will always be at least one RTO that will be responsible for accompanying the development on each application experiment and provide help if it's needed. If for some reason the technology provider is unable to respond to all the challenges, it's the job of the RTO accompanying the project, or the SDM, to see and help how best he can. And of course, as I mentioned, we have a business development partner inside the application experiment at the same time, that which has the job of offering help or helping the IC in developing a business plan for after the project. In terms of application areas, we don't have a specific area where we are trying to focus our attention. As I mentioned, we are trying to promote the adoption of flexible and wearable electronics, and to do so in all areas of society and industry. We have here 8 examples: automobile, consumer electronics, energy, packaging, and so on. And so we try to not focus on a specific area and more work in terms of the proposals that the IC bring to us. As a side note, just for example, one area that had particular attention in the last year in the already submitted application experiments was, of course, health due to the COVID problem, where we had several projects being proposed related to this problem. With all these application experiments, we are trying to help in the redefinition of electronics and how they are seen by the user and the normal consumer, by trying to better or adapt some concepts and devices that to help adapt it and prepare it to be applied in the creation of functional and usable devices, or let's say, for example, textile structures. We have here the example of smart textiles as a final structure and an idea and a concept. With next to it, we have flexible batteries and flexible sensors that are examples of devices that can be used in the creation of smart textiles. In terms of project, in total for SmartTex2, we had an increase. You can see here that we had a small decrease from SmartTex1, but the idea is to support a larger number of application experiments. You can see here that our proposed total amount at the end of the project, we increased from 20 to 47. Of course, this this is how much we can have for each application experiment, not the total. As an example of, I mentioned before the composition of each application experiment. We all have 3 partners working, the IC, the business partner, and 1 technology provider, which can be from outside the consortium or from inside. And this creates several types of support, financial support, with 1 example of them being shown here, where we have here the 20K being already, we have a maximum of 100K support, 20K for direct non-tech support, tech service provider, and 8K being supported to the IC, from 8K being divided between 20K to the IC and 60K to the tech supplier, I'm sorry. Of course, of this, we follow rules from European project with 70% support for the final project. So let's say for the tech supplier to receive 60K, they have to provide us with or submit a proposed budget of 85. As for the process for submission and for the application experiments, we start, of course, with the preparation and submission of the proposals by the ICs. There can be a small discussion between the ICs and some of or one of the RTOs if there is already a connection, or if they find the RTO that they might need. And also the submission should be done through the help desk. After the submission of the proposal by the ICs, there will be a small period of 2 months where we'll have the evaluation by selected experts. For each cutoff, we have at least 3 experts, 2 from inside the consortium and 1 invited from outside the consortium. After this, after the evaluation of all the proposals and the selection of the ones that present the necessary conditions to be approved with an attractive idea and a well-developed business plan, for example, of course, we'll let the IC know that they were selected and start the preparation of the joint service planning, where a work plan will be created between the ICs and the technology provider and the business plan provider as well. After this JEEP or service planning is a joint implementation plan, is created and approved by the coordinator of the SmartTex2 project. It will move on to and start the development itself, which, as I mentioned before, should have a duration between 9 and 12 months. As for the cutoff dates, the project has already had 3 cutoff dates previously, with 2 remaining until the end of the project. The next one will be in May, and the final one in August of this year. As you can imagine, since it can have a minimum duration of 9 months, it should end before the end of the SmartTex project itself. Another service that we provide to ICs or to any SME or person of interest that is interested in learning a bit more about flexible and wearable electronics is our ecosystem, where you can, if you access our website and go into the ecosystems side of it, you'll see several areas. First, for example, we have the technology marketplace, where anyone can register and offer their services in a specific topic or technology. Organization registry, or besides the RTOs from the project and already the technology provider partners that were identified in the beginning of the project. Anyone, if an organization so desires, can also go and register their services to be provided to someone that might need them in the future. The business marketplace and also the community. We have here areas before this. In the top, you can also find skills and training area, for example, where training material, webinars, books, white papers are provided for the community to learn more about the topics. And also, for example, virtual tours of the facilities of the RTO partners. You have here some examples of the technologies and products that are provided in the ecosystem. This already has expanded further, but as you can see here, we have things from just capacitive sensors to biofuel cells and other topics and devices. Here you can see some success cases from Smarties 1 and other previous projects. Where we had, as you might remember, we had the objective of having 20 application experiments, and these are some of the projects that came out from those application experiments, from smart lighting to smart building, medical shirt and health, motorcycle jacket. As for Smarties 2, we are still in the process of finalizing the application experiments from the first cutoff. So we don't have currently any example here from application experiments from Smarties 2 itself. Guys, please don't forget, if you have an idea of a project that you want to develop or you want to industrialize, please feel free to reach out for us and we'll try and help you as best as we can. And with the next cutoff being in the 7th of May this year. Thank you for your attention.
Okay, thank you very much, Jose, for this interesting presentation. And what is really also really interesting for you is that first of all, there's still funding available, so it's a great opportunity for you. As you understand, there's still 2 calls which are running. And the other opportunities is that obviously, if we want to success in smart textile, we need to meet 2 different universes. The one which is the textile universe and the one which is the electronic universe. And through the community of Smarties, you have access to the electronic universe, and so it's also a great opportunity to meet and match with some new friends, which can bring you a lot of ideas and probably supports. Basically, we have still a few minutes for questions, not so many, but what we can promise also is if you have some question you can raise, and we will answer them later in the chat and in the follow-up of this meeting. So perhaps first question is to Zhao. What is missing to fill the gap? Is there more technical issues or it's more markets? What is the maturity of smart textile solutions?
Well, it's a very difficult question, but I believe that at this time, I think we do have some technical challenges that we need to overcome, specifically on the interconnection technology that we discussed, but also on the data management integration that we also discussed during the presentation. And since the data management and data acquisition platforms that need to be integrated into a lot of these systems, Judith knows that when we were looking at projects in SmartTex, that was always the biggest hurdle, technical hurdle that we had, is how to integrate a service model in to these devices that makes it at least market appropriate or transferable to the market as a product. If you consider any other electronic product, you always have a service model attached to it. And if you consider also a normal textile product, technical or non-technical, it also has some, at least a lifetime compatibility model that you need to use. So first and foremost, I think that we need to overcome some of this compatibility issues, because we're integrating two different industries or two different technologies into a single product, and that normally takes some time. We do have areas where success is more accelerated and the market is more willing to incorporate that value, namely technical applications for automotive, for instance, in which textile coverings and textile surfaces are normally used in different structures, and you do have some degrees of freedom there to explore. But when it comes to specifically wearables, we still have some technical hurdles that we need to overcome, specifically on the integration process.
Okay, thank you very much. Okay, we have, because we will need to give back the floor at in 2 minutes for the B2B meeting. So just perhaps a final question, short question, but short answers. Of course, smart textile needs a supply chain. Is there enough suppliers along the value chain, or if there's also opportunities to fill the gap? And because obviously, as Chao explained, there's a strong need from the user demands, and you need to think from the user demands if you are on a final product. But along the value chain and along the supply chain, there's perhaps still some opportunities. For example, yarn producers or weavers, I don't know. But from the textile point of view, is anyone have some ideas about the supply chain and opportunities on it?
I mean, I think that your supply chain is there, and we have the technology to really produce smart textiles. But I mean, that's something that we find as well a lot in SmartTex is that, I mean, we have some prototypes that they didn't think about the existing technology to be produced in Europe and the existing companies to be produced in Europe. So then we have a prototype that has made in a way that it's really difficult that can reach production stage. What we really suggest them maybe is to first look into the technology that there is, because for example, we have knitting technologies to add electronics. So what we ask is first look at the technology and later produce the prototype.
Okay, thank you very much. If you still have any question, you can send it to Anna, and we will be pleased to answer it later. So it's time to leave, and it's time to go back to B2B meetings. Thanks a lot for your participation. Thanks a lot for the speakers. Thanks a lot for Citeve and Santi for hosting this event. And we will don't miss the presentation tomorrow about technologies and fashion. Thanks a lot. Bye-bye. And take care, everyone across Europe.
Bye-bye. Thank you.
Bye. Thank you.
Bye.